What is a Hohmann transfer orbit in space travel? Imagine needing to move a satellite from one height above a planet to a higher one with minimal fuel. That's where the Hohmann transfer orbit comes into play. It is a simple, efficient way to change a satellite's orbit using the least amount of fuel. This maneuver is like taking the most direct route between two points in space, saving energy and resources. The process starts with a spacecraft in a circular orbit close to the planet. To reach a higher orbit, the spacecraft fires its engines briefly in a maneuver called a burn. This burn increases its velocity, pushing it onto an elliptical path called the Hohmann transfer orbit. This elliptical orbit stretches from the lower orbit to the higher one, crossing both at specific points. The farthest point of this ellipse is called the apogee, which is where the spacecraft reaches its highest point. Once the spacecraft reaches the apogee, it performs a second burn. This burn adjusts its velocity again, making the orbit circular at the new, higher altitude. Because the burns happen only at the points where the orbits touch and the velocity vectors align, the maneuver uses the least amount of fuel possible. This method avoids unnecessary changes in direction, making it very efficient. The idea was first described in 1925 by Walter Hohmann, a German engineer. Since then, it has become a key technique in satellite operations and interplanetary missions. For example, India used a Hohmann transfer orbit to send its Mars orbiter from Earth to Mars, saving fuel and reducing costs. When traveling between planets, timing is everything. Spacecraft launch during specific windows when the planets align just right. For Earth to Mars, these windows happen roughly every 26 months. The spacecraft travels along half of the elliptical transfer orbit, which takes about 9 months to reach Mars. In essence, a Hohmann transfer orbit balances the need to change velocity and the shape of the orbit to move efficiently through space. It helps satellites reposition and makes interplanetary travel more practical by conserving fuel. This method continues to be a fundamental tool in space missions, helping us explore our solar system with less waste and more precision.